pointers in general in programming, and a little bit maybe pointers in Go languages. Go language. I have been learning Go language, and I love it. And I definitely recommend you to learn Go language if you want statically compiled languages, the power of statically compiled languages, and the simplicity of dynamic languages, syntax like Python, Ruby. Anyways, I will probably make another video for explaining Go language and its power and syntax, whatever. So let's start with the pointers. Pointers are very strong constructs in programming, but unfortunately some people are confused by pointers because of the interaction it causes. So you have to think a little bit different when you think about pointers. But just rest assured that pointer concept is extremely easy once you understand it. So let's start with analogy. In our daily lives, we actually use pointers a lot, especially when we give addresses. For instance, when you want to invite your friend over, you say, hey, this is my home address and come by, right? You don't really give him the home, the actual home. You say, hey, this is my address. So let's actually draw that on here. So let's say you have two friends and you want them to come to your house for, I don't know, dinner. So you have two options. In fact, if you think, you can say, hey, you can say, hey, this is my home, right? And you can just copy your entire home, like build your entire home from scratch. And in fact, you can build two of them in scratch, so you can have one more of the same house and say, hey, this is my home. And you see this the silliness of this approach. You basically say, come to my home, and then you give, the exact copy, of your home, and look at the amount of work, resources, and everything that you will spend with this silly approach. So, and then it takes time, money, whatever, all the resources, and but you have another option, and that is, you say, hey, you can write on a piece of paper, you can write your address, right? And you can say, hey, this is my home address. Look at the simplicity, easiness of this approach. It consumes just one piece of paper instead of you rebuilding the entire home twice. And then people know this address and they come by instead. So the second benefit, so the first benefit was you eliminate resources, right? And it is simple to construct because you just write it on a piece of paper. It is simple to construct, simple to use, simple to carry around, right? So all those beautiful, all those benefits. So the second benefit of using an address like this guy is, if your friend, let's say, your friend says, hey, I have some time before work, or I have some time after we meet, I can stop by at your house and prepare something for us, right? You can say that, hopefully. And then when that happens, he can just come to your house and then, prepare some, like, burgers, whatever, just kidding, but yeah, you don't really want to eat burger in your dinner. And then some other food, drinks, right? And all the other things. So what happens, since you guys share the same home, when he prepares dinner in this home, in this shared house. You guys will go to the same house and then you will see all this food, right? But what happens when you actually give them the actual duplicate of your house? So if you did that, this person will prepare the food here in this house, but you guys would go to, like, you would go to your house and this person would go to this house, but they're not gonna, they wouldn't see the food because the food was prepared in a different house. And that's all simple. So from that we say, when we want to share the same resource so the others can manipulate, then we use pointers. For those who come from languages, I hope it is very clear for you guys. It is the pointers. So let's say this is your address. Okay, but when you define a pointer with this asterisk or star letter or sign, you say, hey, my home is, I mean, I'm not sure how can I explain this, but you say, hey, my home is addressable, whatever, and you say, or you say, I don't know, or maybe, okay, let's think about this. When you talk with your friends about your home, you say my home, right? Okay, and you say my home, and in fact, this my home indicates an address to your house. Let me just do this a little bit. Okay, so my home indicates an address to your house. This is pointer, and it points to your house. Okay, and this is all. And so let's use an example. So let's say you have a method which says invite. I'm gonna write like a neutral pseudocode type of thing, but we'll use the popular pointer syntax. So you have a method which is invite friend. Okay, and then invite friend accepts. Let's actually do this so that you can see it better. Okay, that's better, I guess. So invite friends accepts a pointer. So the pointer, this is in Go syntax. Probably use Go syntax, and you say house and house. Okay. This is Go syntax, and Go syntax type come after the variable name. In this case, it's a parameter, so the type comes after the parameter, and this indicates this is a pointer. And then and this friend come over to your house. And how do you know that your friend is in the house? Well, one option is you can have in this house, let's say this your Go language does not have classes, it has structs. But for those who come from C# or Java, struct is similar to class in terms of like how you kind of use it. There are differences, but let's, for the sake of simplicity in this video, let's keep it simple. Let's keep it that way. So let's assume they're similar. They're the same thing. So in your house, this is how you define a struct. You say this is a type. What is the name of the type? House. And what is the type? Type. So it's a struct. That's how it works. And you can have a property or a field number of people in your class, in your struct, and that's how you know that your friend is arrived at your house. So in this case, I say house dot number of people, and then just plus plus. So this will increase the number of people. So it's and you see that since it's a struct, what you're passing here is a reference, is a house, the address of house. This is the address of house, and then when you access this like that, normally though you will expect to do this. You say, okay, but Go language is giving you a kind of a simpler syntax when it comes to this type of thing. You don't have to decorate your struct with that notation like this with a pointer. You can just say house that number of people instead of asterisk house number of people. But yeah, they're two same thing. So what do you do here? Okay, let's explain a little bit. So this house, okay, it actually stores an address. So this is the, let's say, 0xabc. Okay. So in your stack or in your memory, the house variable or the house parameter stores an address of another memory location. So it goes to somewhere else. Okay. And this is where your house, the data of your house is stored. And the address here is ABC. So, as I explained before, instead of copying the house and then passing that around, you just pass an address of the house, the memory address of the house, and pass that around instead, so that you can share the same instance, same value, and then you don't have to copy and move a block of data around, and that will help you to increase the performance of your application, and so on. So if I just say like, if I print the house without any asterisks or anything like that to the command as an output, okay, what I'm gonna see in the output will be the address. That's it, the address value. But it's not useful to me. I don't care about the address. I care about the actual value. So you have to use, and in order to say that to the computer, you say, hey, I don't care about the address. I don't care about the actual value of the house. I care about where the house is pointed at. And to say that, you say this star or asterisk sign and house, and that will actually say, okay, the compiler or the runtime will say, oh, it wants to get the actual value, not the address, so I will go there. So that's how you use it. It's very simple. Is it enough? No, we have to call this invite friend, right? And let's invite friend, call this guy. But you have to have a house created in advance, right? So what you can do, I'm just gonna write. Let's remove this. I'm just gonna write it here. What it says, you have to create an instance, and the one way to do that is you can say var. I'm gonna use the longer syntax. There's some shorter syntax, but in order to explain ampersand, I'm gonna use the shorter, longer syntax. So let's say var house, just h. Type is a house. Okay. C#, local variables are automatically initialized, so you don't have to say something like new or something like this. It's fine. Or you can just use, I mean, it's really language features, I'm not gonna go into that, but just know that this is initialized by, at the time I say this, it's initialized, and the house is a value, and house has the number of people here is 0, so if I say h dot number of people, and that will be 0, it's already initialized. So in other languages like C# and Java, you can't really say this in your methods, in your functions, because it doesn't accept it. You have to initialize it manually by saying either new, if it's a class, or 0 or false, whatever the type of the value, type of the variable is. But here in Go language, it is fine. Okay, so if I say invite friend, okay, and now I'm calling the function. But you may say, hey, how I'm supposed to get this h is not a pointer. It's an actual value. It actually, this h, it really goes to an actual h really goes to an actual value. So when you say h dot stuff, it is the house, not the address. So I'm supposed to do this. You need, and what we understand from here is that I need to access the address of h. I don't want to pass the h, the entire house. I want to pass the address, like in this, the address of the house, not the house itself. And we have another sign. It is called the ampersand. Let's do this. Ampersand like this, and then this. At the point you set this, you say the compiler or runtime, hey, this is, I'm passing the value or the address of, hey, h. And now it is compatible with this because this is in fact an address, okay? House stores an address. It is kind of a special type. It says, okay, I am an address, but I will point at a value in a memory that is of type house. So that gives you a kind of a strong compile time checking, because you cannot assign a different value to this guy's, because it knows its actual, it knows the type that it points at. So that's good. In fact, it's really good, right? I mean, when you think about this, you would assign any type of value to your pointer, and that will confuse you because you don't really know what type it is. And since you don't know what type it is, how do you know how to access to that type? Because it can be abstracted with a bunch of fields like this, or it can be integer. What if you try to say, what if you try to access the number of people field from an integer value? That will throw a runtime exception, right? So this is what we see here. It was awesome. And in fact, think about this analogy. What if, like, the house? In fact, what if that the address of your friend, but you don't know if it's his house, if it's someone else's house, or if it's a storage room, or if it's a big office building. How do you know that? And it will confuse you, right? But you know that this is his address, and that will give you the confidence, and you know that you know how to where the kitchen is, maybe where the living room is, kind of stuff, and that makes you confident about the type and how you access and how you utilize this type. possible if it's something else. So this tells us another thing, is that this address has also one more information, and that is the type of the address, or type of what this address is pointing at. So it is my friend's house. This is really simple, guys. I mean, I'm sure that you already have understood what I've explained here. Very simple concept. So this is all. So what we know from here, we know that when I define a pointer type, I define it like this. So I say house. In C# and in Java type of language, you would just swipe the type and the name, and you will be fine. And so since this house is really an address, unless you use it with asterisks like this, you don't have to say this because, or offer this, because it will be like address of an address, and that will be stupid. I mean, there are cases where you need it, but in this case it doesn't make sense. So you just say, if you want to get the address and that's it, just use a house. But if you want to get the value that the house address, the value of the actual house, which is located at the address, this pointer, this house includes, contains, has, whatever, then you say ampersand, you say this thing, and then house. I'm not sure if you guys see it clearly, but you may have to make it full screen to see my writings here. But I'll also explain what I write. So, but what if, like, you have a variable which is not a pointer or nothing like that, just a simple variable which can be of type house, int, string, whatever you call it. But you need the address of that because your function accepts a pointer. Right. So how do you do that? That is where ampersand sign comes into play. So let's say you have another variable called my house. Okay, and this is just house, no pointers. You see that this is just normal house variable, no pointers, nothing like that. But I need to get the address. This is where the ampersand is useful. You say ampersand my house, and now we basically get the address of your memory, where the house object is located. So let's look at the memory structure a little bit. Sorry, I got a message. Okay, I got a message, but yeah. So, let's look at, I'm not 100% sure about the memory layout of, like, how Go language manages memory, but I know how C# and Java does that. So, I mean, in C# and Java we have stack and heap. Okay, and stack is where your local variables and parameters are stored, and heap where your objects are stored. So that's it. And stack is basically a stack structure. A stack data structure, which is really like you put the data in and you put it out, serve first in, last out, filo, or last in, first out, LIFO, whatever you call it. Heap is a different data structure. The data can be here, be here, be here. I mean, it's not like a stack. It's more like I wouldn't say random, but it's more like a unstructured type of thing. So when you do this, so if your data is stored in heap, there is, well, maybe I should explain this in a different video because it takes a while to grasp the concept if you are not familiar with this. So explaining here in an overall fashion will actually confuse you more. But the idea, let's forget about this. Okay, I'll just go ahead and disable. Alright, that's better. So, okay. So, when I say memory address, I explained that before, but let's say this is 0, this is 1, this is 2. What it means is this OX. It means that the number, it's only a kind of a representation that tells us that the number here is an hexadecimal format. So hexadecimal. I mean, it just tells me, okay, this 0 is in fact in the hexadecimal format, and 1, 2, and it will go A, B, C, D, right? So that's in the kind of a explanation of the number you use. You don't have to use it, but it's a good practice to use it. So you have a data here. Let's say your house object. Let's look at it here. Of course, house is a big object usually, and it will take more than one. These are bytes. So they're like just their physical memory byte of I mean, it's really like this, kinda. But you basically store like bits. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 8. They're all, you can store 0, 1, 0, 0, 1, 0. Meaning like there is electricity here or electron here, and there's no electron kind of thing. Like it's kind of thing. Anyways, and this is 1 byte. 4 and 4, so 4 bits. 4 bit, meaning byte, 8-bit. It's a byte, and not bytes, byte. So you probably will have a big portion of your memory here, at least, to store the bytes of your house object. So anyways, but this is this is where your memory, your object is located, and this is the address that you're interested in when you use pointers. This is the address, and you say when you pass data, you pass this address, and then you store the address of this guy in a variable in different location of memory, and you store the address of this guy. Let's say this is 0x0. Okay, you store this address and you copy this address all over. Like when you assign this pointer to a different pointer, you basically assign this guy to a different pointer. You copy this guy, not this guy to a different variable, different parameter. Or if you're accepting it as a method, as a function, into a function, and so on. So every other variables are always using this, are all pointing at this, and once you use this asterisk, you basically tell, hey, I don't care about the value here, I care about the value here. So that causes an interaction from here to here. This is called dereferencing. You reference from something to something else, from something to something else. This is called dereferencing. Alright guys, I hope this is enough explanation. Let me know if you need further clarifications. You can just put a comment below and I'll go ahead and explain them as well. But this is all about the pointers, addresses, and always resort to what you know in real life and you don't understand something in programming, because you realize that programming is really like the real life. I mean, there's a lot of similarities between programming and real life, and you 99% of the time will find analogy that you can use from the nature when you don't understand something in programming. I hope it's clear, and you guys have a great day.